Hello guys, welcome back. So in this video, we'll see about a question on network theory from GATE 2016, and it is an interesting question. In the portion of the circuit shown, if the heat generated in 5 ohm resistance is 10 calories per second. So heat, usually whatever we have studied is given in terms of power, which is in watt. But here they have stated it is as calories per second. Calorie is nothing but another unit of energy. And the SI unit of energy is actually joules. And watt is nothing but joules per second, right? And here they have given it as calories per second. So this is power. This one calories per second. So then the heat generated by the 4 ohm resistance in calories per second is dash. So this they have given us 10 calories per second. They are asking what is the power generated here. So for this question, do we need to know the relation between calorie to joule conversion or anything? Not at all. Because anyway it is gonna get cancelled once we take the ratios. So here what is given? So 5 ohm generates 10 coulomb per second. Sorry, calories per second of heat. So I'll write it as CAL per second. And let us assume that the current flowing through this is I. So power in watts is nothing but, we know that it is I square R, where I is in ampere and R is in ohms. Now power in calories per second, let us say that there is some constant K which converts watts to calories. So it is K I square R. But if you observe, always the power is proportional to your I square and it is proportional to your resistance. So to find the power in 4 ohm, what we have to do, we need to find this current I dash and R we already have. So from the given relation, what do we have? 10 is equal to K into I square into 5. So K I square is equal to 10 by 5, which is equal to 2. So this is one relation we have. So here if you effectively see, so here you have effectively 10 ohm and 5 ohm. And the voltage across them is same. Which means that if I is flowing here, this is a resistance of 2 times. So by Ohm's law, I by 2 should flow here, right? And if you have the current flowing through the resistor and the resistance value, we can get the power. So our power of 4 ohm in calories per second is nothing but K into this I prime square into 4. I prime is nothing but I by 2. So K into I square by 4 into 4. So which is nothing but Ki square. Ki square we already got, which is equal to 2. So the power dissipated as heat in 4 ohm in calories per second is equal to 2. So 2 calories per second. So here if you see, the K got cancelled when we substituted from here to here. So we are only interested in the ratios. So seeing the question and thinking it is asked in calories per second, you actually needn't know what a calorie means. You just need to know that it is some unit of power. Even if you ignore this K, even if you substitute it equal to 1 and then try to solve it, you will still arrive at the same answer, because K never matters in the totality of the final solution, right?